Hello, my name is Kenneth Anuforo, and this is a presentation of my proposed project for the Research in Computing module. The title of the project is Student Assessment Performance Prediction from Interaction with Virtual Learning Environment using Machine Learning. A brief introduction. Despite the importance of education in the life of an individual and the society, the conventional classroom style of education has been unable to meet the growing population of people who want a formal education due to factors such as high tuition and distance. This has led to the rise of online education platforms known as Massive Open Online Courses, known as MOOCs for short, to address the need to not be physically present in school. Also, over the past decade, there has been a digitization of many learning activities, such as lectures being given out as video lectures, either in real time or pre-recorded, assessments occurring over the internet, and student-faculty communication occurring on dedicated learning platforms. This digitization, as with all other digital activities, generates a lot of data, which when data analytic techniques are applied on, can generate insights to guide decision making. As shown on the screen, the research question that this project proposes to answer is: how significant is student interaction with a virtual learning environment in predicting the performance of students in a module? The primary objectives of this project are to deliver a machine learning model capable of predicting with a high level of accuracy whether a student will pass or fail a course, and to conduct a statistical analysis with the purpose of knowing the extent to which student interaction with the virtual learning environment contributes to predicting whether a student will pass or fail. Knowledge of these can be used to design intervention plans so that students who are at a risk of failing can be helped to avert such. The proposed approach for answering this question is discussed in the methodology, design, and evaluation sections, which are discussed next. A literature review was conducted to understand the works that have been done previously on this topic. The purpose of this task was to get familiar with the state of the art in the area of learning analytics and to identify gaps in the literature for formulating a research question. The scope of the literature reviewed includes the choice of data features for modeling student performance, the evaluation metrics for classification problems in student performance, the choice of machine learning algorithms for modeling student performance in online courses, and methodologies already used for tasks in this area. The proposed methodology for this study is the cross-industry standard process for data mining, also known as CRISP-DM. The CRISP-DM methodology is preferred to other methodologies like the Knowledge Discovery in Databases, or KDD, as it requires a business understanding which is necessary to put the problem in context. There are 6 steps to this proposed methodology, and these are business understanding, data preparation, data modeling, evaluation, and deployment. As a brief insight, the project begins with a business understanding with the goal of understanding the background of the project and the context in which the problem is considered. This was achieved through a review of literature previously done on the topic and the area. After this, an understanding of the data is achieved through exploratory data analysis and graphical representations of the data. With an understanding of the data and knowledge of the features necessary for building the model, the next stage is the preprocessing of the data. After cleaning and preprocessing the dataset, the features are transformed, including feature engineering, to generate better features with higher predictive capabilities. Having prepared the data for machine learning, modeling is carried out on the dataset. A number of machine learning classification algorithms, including random forests, naive Bayes, and decision tree classifiers, are proposed for the modeling, and after the modeling, the models will be evaluated using evaluation metrics such as accuracy, sensitivity, specificity, and precision. The best performing model will be selected. The proposed design specification for this project is the 3-tier design specification, comprising the client tier, the business logic tier, and the data tier. The diagram shown on the screen shows the proposed design where the user interacts with the data tier by issuing queries which are processed by the business logic tier. At the logic tier, the query is processed by running the model to predict whether a student will pass or fail based on the features of the data passed to the model. The proposed tools for implementing the client tier are Tableau and RShiny. The tools proposed for the business logic tier are RStudio, dplyr, and Caret, which are R packages for machine learning. And the proposed tool for the data tier is MySQL, which will hold the data for querying. The proposed research plan is as shown on the screen, with the project implementation phase expected to run for 13 weeks from September to December 2019. The breakdown shows the number of days allotted for each task, with reporting and documentation expected to take most of the time at 23 days. Also, the resource person for all tasks is myself, Kenneth Anuforo, and that concludes this presentation. Thank you.